So today we start our official review to get ready for the test May 4th. So we've got 4 full weeks of review leading up to the test. And I've got multiple choice questions that cover everything, like grouped by topic, and free response questions grouped by topic. So we'll see lots of, and most of these are previous AP tests. So we'll see lots of former test questions, and we'll review it by topic. So we'll hope to accomplish a couple things at once, like review everything, obviously, but also get a feel for what the test questions look like. And even some of the scoring guidelines, we'll do that today. Like how to score, not that you need to know it for sure, but just to get a feel for what they're looking for when they're scoring a free response question. So it may feel like it's out of order, but I try to put the stuff together and in order as best as possible. I'll give you the packets by week, and so in a minute I'll give you this week's packet, and you guys are online, you might see that it's already posted, this week's packet. And we'll kind of just play it by ear on what we want to do in class versus homework versus how much I do and you do. And so the point is to get through the stuff and to see it and to remember it, review it, so that you're ready. The other thing I want to do today is give you a stuff you must know cold worksheet, or formula chart is a better way to say it. It's this nice, pretty green color. This is a blank one, so this is for you to sort of fill out either as we go or take 30 minutes one day and fill it all out as best you can. There's a few things on we haven't done. So let me hit pause, pass it out, and we'll fill out a few things just as a review and to start the review process. What is the first one? What do you mean when you know the first one?
Oh, we're talking about under basic derivatives.
Okay. So what's the derivative of x to the n? Not focusing, right? But yeah, there it is. Bring the power down, reduce the power by 1. So n times x to the n minus 1. What's the derivative of sine? Cosine. How about the derivative of cosine? Negative sine. Derivative of tangent? Cotangent? Well, it should go with tangent, right? It should be something similar.
Secant, tangent. Secant squared, tangent.
Let's see. If tangent goes to sine went to cosine, cosine went to negative sine.
Cosecant tangent.
Tangent went to secant squared, so cotangent's going to go to cosecant squared with the negative. So those kind of go together. How about the derivative of secant? Secant tangent. The derivative of cosecant? It's going to be negative because all the cos are negative. And then look at what secant goes to, and cosecant will go to cosecant cotangent. What about the derivative of the natural log? 1 over u. And they did it in terms of u, so we should probably do 1 over u times either u prime or du dx. It's kind of reminding us to use the chain rule. They probably all should have been in terms of u. That way they all had a chain rule reminder. How about the derivative of e to the u? E to the u times du dx. So we'll stop there. You can fill in more. We can go over more later if you want to. What I want to do today is use a little bit of the blank space on the back to remind you of one we maybe haven't seen in a while, because it's the problem we're going to do today. And that is if you integrate a rate, do you remember what happens when you integrate a rate? You get the change in the amount. So if you went from rate 1 to, or if you integrated from 1 to 2 of the rate, it would be like the amount at time 2 minus the amount at time 1. If you integrate the rate, you get the change in the amount. All right, let's put that aside. All right, so this is from 2015. This was the question that the students in 2015 got, or one of the 6 questions. There's always 6 free response questions. There's 2 with calculator. You get 30 minutes to do those. And then there's 4 no calculator. And you get 60 minutes to do those. So you have 15 minutes per question, but you don't have to spend 15 and 15. You can spend 10 and 20 or 5 and 25 or however you want to do it. So this would be the calculator part of the free response part of the 2015 test. All right, the rate at which rainwater flows into a drain pipe is modeled by the function r, where r is that thing. And let's see, that's the rate going in, cubic feet per hour, from 0 to 8. The pipe is partially blocked, allowing water to drain out the other end at a rate modeled by this thing. So r is like for rain, the amount going in, and d is for drain. So you got some going in and some going out. 0 to 8. There are 30 cubic feet of water in the pipe at time 0. So that's how much, that's kind of the starting point there. Part A, how many cubic feet of water flow into, so we're dealing with R, the pipe during the 8-hour interval? All right, so R is the rate going in. We want the total amount that flows in. So how do we get from a rate to an amount? Yes, we'll integrate, because the integral of the rate equals the amount. Or equals the change in the amount is a better way to say that. So let's integrate from 0 to 8 r of t. And again, r of t is defined, so I don't have to rewrite what r of t is. Some of you used that well on the last test. Others of you tried to use it, but then you used variables that weren't defined, and so I couldn't give you credit. You almost did that. Like some people said, like the integral of g or f. They're like, well, there is no f or g in this problem, so I don't know what you're talking about. I mean, I think I know what you're talking about, but you got to use the variables that are there. If you don't like the variables that are there, you are welcome to change them. You are allowed to change it. If for some reason you are opposed to the letter r and you want to say, I want to use f and g, then that's fine. You just have to say f of t equals r of t, and you can use f the rest of the way. I mean, I don't know why you would do that, but it's legal, and you're allowed to do that. Back to this question. How many cubic feet of rainwater from 0 to 8? So I'm ready to go to the calculator and just type that in, and that'll be my answer. So Math 9. Although I could do the thing where I put it in and look at it and see, and then integrate with y1 and y2. I think I'm just going to type it in, though. It better be in radians, which I almost was not. (20 sine of x squared over 35). I'm doing it in x, and just, if you want to put them in t's, that's fine. And so my answer is supposed to be 76.57. Checking against the key here. 76.570. What would the units for that be? Yeah, feet cubed, because it's an amount. Now, it didn't specifically ask for units, so that's your hint that there's not a point assigned to the units. And so if you didn't put the units on there, you would be okay. And since they're not looking for it, if you put a wrong unit on there, it wouldn't take off. I don't think that's kind of dangerous. So that we're done with part A. Part B. Is the amount of water in the pipe increasing or decreasing at t equals 3? Give a reason for your answer. Well, let's see, the amount of water in the pipe. But is it changing? So we want like the water change. Well, would that be, what would that be in terms of R and D? R and D are both rates. We want to know about the rate. So R is the amount going in, D is the amount going out. So we'll subtract D from R. R is going in, D is going out. So that means at 3, I don't know, water change, we really want to, at t equals 3, let's just say R of 3 minus D of 3. That'll tell us if we're increasing or decreasing how much is going in there. And that's all I need to show for like show and work, because R is up there. So now I'm just going to type in R of 3. I don't know if this would have been easier to put in y1 and y2 or not. 20 sine 9/35 minus, that's going to be yuck, negative 0.04 times 3 cubed plus 0.4 times 3 squared plus 0.96 times 3, close parentheses, so negative 0.314. And that's in feet cubed per hour. So that's the sort of the net change in the amount of water in the pipe. So more is flowing out than is flowing in. So let's make sure we answer the question. Is the amount of water in the pipe increasing or decreasing? Well, decreasing. Because R of 3 minus D of 3 is negative. So more is flowing out than is flowing in. Part C. At what time is the amount of water in the pipe at a minimum from 0 to 8? Justify your answer. So I want to find a minimum. Well, a minimum happens where, well, it might be at the endpoint, so we need to check those. But let's see, that would be where, maybe where the, how do we say this? The water in the pipe, the change in the water, I need a different variable here. The water in the pipe I'm going to make W equal the water in the pipe because I keep needing to talk about that. So I want the minimum W. So I need some critical points. I need to know when W prime equals 0. Let's see. I'm also going to need to figure out how much water is in the pipe. So if I integrate the rate, I get the change in the amount. So let's see. And W is the amount. So I'm going to integrate from 0 to t. Let's get the signs the right way. R is what's going in. D is what's going out. That statement's not quite right, because that would be the net change, but it started with 30. We started with 30 in there. We'll integrate to get the change. So here is the amount of water in the pipe at any particular time. So if I want W prime, well, the derivative of the integral just goes away. W prime would be R minus D. Right? That makes sense. The change in the amount of water is the rate going in minus the rate going out. I think we should graph that and see what is going on here. So I don't have to say this, but just in case I use them later, I'm going to let y1 be R and y2 be D. I don't have to put that, but I'm going to put it to help me keep it straight, and if I goof up later and use y1 or y2 in my answer, if I've got this, then it's okay to do that because I told the grader who's y1 and who's y2. Question?
Would W prime be R minus 2 plus 30, or does the 30 go away?
30 goes away because the derivative of 30 would be 0.
Okay.
So good question if we're taking the derivative of this. So y1 is 20 sine x squared divided by 35. y2 is the amount draining, negative 0.04x squared plus 0.4x. Nope, did that wrong. X cubed plus 0.4x squared plus 0.96x.
This is cubic, not a sine.
So who knows what that thing looks like? I could figure out, well, it does them in order, y1 to y2. Window, I'm going 0 to 8, so I'll just go negative 1 to 9, just to get a little extra to look at. Y value, I don't really know what to look for there. I don't know, I'm just guessing here, see if that works. I went up to 20. Hey, that was perfect. Unless this one doesn't work well. Okay, so those are the rates. Let's see. At a minimum. So minimums happen when the prime is 0 or might be at 0. Right? Critical points, and then we'll check to see if it's a minimum or a maximum. So I want to know when that's equal to 0. So what I really want to know is when R is equal to D. Because something might be changing then. We're changing from more going in to more going out. Second calc, there's an intersect button. So first curve, second curve, guess. So there's an intersection at 3.272. if I really wanted to be careful, let's see. I'm going to make the rain going in a darker shade so I can tell which one's which here. So that's the rain going in. There's the rain going out. So up until about 3, there's more going out than going in. After that, there's a whole lot more going in. So I think there will be a minimum at 3.27 whatever. But I just need to do a table of values here. We started at 30. Up to 3.2. More was going out than was going in. So this number should be smaller than 30. So I'm going to math 9 from 0 to 3.272 of y1 minus y2. I need to be careful though, that's the change from 0 to 3.5 hours, or 3.2 hours. So it went down by 2, but that's not how much water is in there because we started with 30. So 27.965. Based on that graph, remember the bold line is the water going in, the lesser line is the water going out. When we do 8 hours, is there going to be more than 30 or less than 30? What do you think? Based on that line. The heavy line is the water going in. The little line is the water going out. Is there more going in or going out? Going in, a lot more going in over here. So I'm suspecting that at 8 it's going to be more than 30. Let's go grab that and go 0 to 8 this time. I'm just going to go ahead and tack on the 30 to the end of that, so don't forget it later. 88.544. So what was the point of all this? Reread the question. At what time is the amount of water in the pipe at a minimum? So at t equals 3.272 hours. Justify your answer. Well, all the rest of the work is to justify the answer. Part D. When we get through with this, I'll go back and explain how many points are on it. There we go. Cheat and do it like this. On the AP test, they space these out, and so each one of these sections generally has half a page to go with it. So you're not space isn't a problem, and not like we're doing on this page. Like again, you'll have half a page to work each piece of a problem. Part D, the pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that give the time w, I don't know why it can't be time t, whatever, when the pipe will begin to overflow. So it'll begin to overflow when it equals 80. When amount equals 80, or not 80, but 50. And it says equation, so it doesn't want an inequality. So I don't want it greater than or equal to 50. Let's just say when it equals 50. So the amount was from 0 to It wants time W, so I guess we'll go 0 to W of rate R minus D plus 30 equals 50. And that's all question D is. So it took some thought, but it didn't take a lot of work, or a lot of writing anyway, is maybe a better way to say that. And that happens on some of these, so you think they generally get harder as you go, and that's generally right. But I would say the concepts get harder. The amount of work shown may or may not get more, because like that's it for part D. All right, now we started that problem, I was looking at the timer at about 10 minutes in. So that took us 15 minutes, that took the full time. But I was going slow and trying to explain everything as we went. Hopefully you'd be going a little bit faster, hopefully you could get through most of it. But let's talk about the scoring now, so you can kind of get an idea for how this would look. So here's the scoring guide that a grader would have when they get together and grade these. Well, because of COVID, they don't get together and grade them anymore. They grade them on their own. But they'd be looking at this, and every free response question is worth 9 points. So you know ahead of time that I don't know how they divide them up, but it's worth 9 points always. So part A, that was from 0 to 8. The integral of the rate equals the change in the amount. That one was pretty straightforward. You got 1 point for the integrand. So 1 point for that, and 1 point for the answer. There really wasn't anything else. So it's pretty much yes or no on either one of those. Part 2, that was increasing or decreasing at time equals 3. So you had to consider both R3 and D3. So consider the fact that there was stuff going in and stuff going out. And then give an answer with the reason. And you could either say R minus D was negative, that's what we said. This answer says that R is less than D, which is fine as well. But either one is an answer, meaning you better have decreasing, that's worth the point, with the reason. So that's 2 points on that part. 3 was a really long one, so it kind of makes sense that they put 3 points on that part of the problem. Considers R of t minus D of t equals 0, so we did that. That got us a potential time. Answer and justification, I feel like it'd be hard to get one of those without the other. It'd be hard to get the answer without justifying. I guess justification might mean you have to check the endpoints. The answer would just be if you just went with the t that we got. So that'd be 3 points. And then the last one was only worth 2 points. 1 for the integral, 1 for making it an equation. So even if you just had this integral somewhere in there, you'd get a point. Turning it into an equation would get you another point. Now, that's a lot of points, but if you can get about 45 or 50%, that's passing. That's a 3 on the AP test. So when you're working these, you're like, man, that was hard. I don't know if I could get all those points. Well, I mean, I hope you run into a free response question where you can get them all. But even if you don't get them all, hopefully you get enough that you can scrape through, and scrape together 4, 5, 6 points and keep you on the path toward making a 3 or a 4. All right, let's flip it over and look at the one on the back. Why don't you try A and B? Because we have time. 9, 10. Yeah. So I'm going to press pause. You guys try A and B because this is what we just did. C is a little tricky, but A and B you should be able to do. A little hint on B. If somebody throws pi in when they're finding the area of a square, I'm going to throw something at you. Grading those tests, one of them was basically this question, cross-sections of squares. A cross-section of a square shouldn't have any pi involved in it, so there shouldn't be any pi involved in part B. or in part A for that matter. All right, I'll be quiet. You try part A and B. It's top minus bottom, but that changes. So it's going to take two statements for R and for S. So you have to use the calculator to find the intersection. Write that down. And in fact, you should probably write down, set it equal to some value. That way you can just use A the rest of the problem, rather than having to write 1.0328319 every time. And you should also save it in your calculator as A for the same reason. You don't have to type that in every time. You just hit A. And once you've identified and named those things, then this is sufficient to show your work, because they used G and F, so you can use that. We told them what A is, so there's our area. Volume of a square, A to 2, side squared, where the side is top minus bottom, so that one's F minus G. Be careful about which one's which here. All right, part C. Let H be the vertical distance between F and G in region S. So F's the top one, so F of x minus G of x. Find the rate at which H changes with respect to x. So that means find dH dx. Well, that would just be F prime minus G prime at 1.8. So F prime at 1.8 minus G prime at 1.8. And you could use the calculator to find those. So you don't even have to, you don't have to take the derivative of this thing by hand. I guess you could. We know enough to do it. But you can let the calculator do that. And you end up with negative 3.812. Now, here's the good news. So that first question was kind of hard. But here's the good news. Part A of this question was worth 4 points. I think most of you got it. And there's your 3 right there. I mean, if you can do that on all of them. Well, 4 out of 9, that's right at the borderline of what gets there or not. Question B was worth 3 points. Most of you got that. So you got 7 of the 9. And maybe if you could get the other 2. But
So, is that all that would be on the AP test? Just that, and then the other side that we just did?
no, because there's 6 free response questions.
Okay, yeah, that's.
There's always 6.
We already got it. You don't even have.
All right, so tomorrow, let me give you the worksheet. Tomorrow you're going to do worksheet 1, just work together, help each other, whatever.